Finding the arc length of a curve is a powerful tool in a mathematician's toolkit. Behind this lies an elegant piece of calculus that culminates in a formula often accepted at face value. We begin by approximating the curve. For every infinitesimal step we take along the x-axis, the corresponding change in the y-axis is governed by the nature of the function at that point. At this scale, the distance between consecutive points on the curve can be approximated as the hypotenuse of a right triangle. The total arc length between 2 points, A and B, is then given by the infinite sum of these infinitesimal distances. The issue here is that we cannot directly integrate because we do not yet have an expression for how dy changes with respect to x along the function. To resolve this, remember that dy over dx is equal to f prime of x, the derivative of the function. This allows us to rewrite dy in terms of f prime of x and dx. Substituting this into the expression, we can then rearrange and simplify to derive a simpler result. This is known as the arc length formula, and it can be applied to a wide range of real-world examples in fields such as engineering, economics, and any situation where determining the physical length of a function is essential.